finally the last chapter, chapter 24, organic chemistry. You will find it very different from the rest of the chapters, and good news, yay, there is no calculations about it, so you're done with the calculations. Good job, guys. Let's start working about working on, let's say, hydrocarbons first, and let's see what is organic chemistry about. Organic, you have heard it and you hear it every day. This is organic section in the grocery store, but this organic is not that organic. So organic chemistry is the branch of chemistry which talks about compounds containing carbon and hydrogen mainly. So we call them hydrocarbons. You see the hydrogen and carbon. So we call them hydrocarbons. So the skeleton of organic compounds is composed of carbon and hydrogen. And since we are talking about carbon, we need to know the structure around this carbon. Around each carbon atom, we must have 4 bonds. So you have different options. So around each carbon, there should be maximum 4 bonds. You cannot put more than 4 bonds. And where did you have it? You had it in General Chemistry 1. You remember the octet rule? 4 bonds means 8 electrons, right? And 8 electrons brings you to the octet rule. So make sure whichever structure you have, your carbons will have 4 bonds. Now, the options that you have for 4 bonds, you can have 4 single bonds, which gives you tetrahedral structure, tetrahedral. If all the bonds around carbon are single bonds, you will have a tetrahedral structure. You can also arrange these 4 bonds as 1 double bond and 2 single bonds. We're not showing any other atoms around carbon because our focus is on carbon. If you have a double bond and 2 single bonds, then you have trigonal planar. You remember, you had all of them in Chem 1, just in case you forgot. You have them here. And luckily, in organic compounds, you don't have a big variety. So just go with what I am talking about in this video. Another option for 4 bonds, you might have 2 sets of double bonds. So what does it remind you? A line, right? So you will have a linear structure. And finally, you may have 1 single bond on one side and a triple bond on the other side. Again, you'll have a linear structure. So your structures are either linear or trigonal planar, or in case of all single bonds, you have a tetrahedral structure around carbon. So we're good with carbon. That's the center, that's the skeleton, that's the main element in organic compounds. So we are talking again about the hydrocarbons that are composed of carbons and hydrogens. We are done with the acids or bases. So we are talking about organic compounds. Of course, we have organic acids and bases, but in this chapter, in General Chemistry 2, we are just briefly introducing the organic compounds too. So we never go to the details in depth, but I want you to learn very well what I talk about in these videos for this chapter. Okay. Now these hydrocarbons, we're talking about the hydrocarbons. We learned about different structures and geometries around carbon, different types of bonding. Now the hydrocarbons can be saturated. Saturated hydrocarbons, they can only have carbon-carbon single bonds. Saturated, they're full. It's like when you're full and you don't have any gaps in the bonds here in the saturated hydrocarbons. You can also have unsaturated hydrocarbons, which I will talk about all of these types of hydrocarbons. Again, it's just an introduction, the headlines. Unsaturated hydrocarbons, they can have either double bonds, they're not saturated, you can add something to them, or you can have carbon-carbon triple bond. Talk about all of these again. And also, we will work on aromatic compounds. Aromatic hydrocarbons. Aroma means smell, means odor, right? So aromatic compounds will have smell. So, in the remainder of the chapter, we will talk about saturated, unsaturated, and aromatic hydrocarbons. Let's start with saturated hydrocarbons. We have two types of saturated hydrocarbons where carbon and carbon only have single bonds. We have alkanes and we have cycloalkanes. You might see different names, weird or different terminology. You are supposed to learn these really well. And organic chemistry does not have that much calculations, but it's more towards memorization. So try to repeat and repeat and repeat until you understand and keep it in mind. So alkanes are the first type of saturated hydrocarbons, means they consist of only carbon, or let's just, instead of carbon, just don't want to inject this into your mind that it's just carbon. No, it can be the single bond of carbon with anything. So the simplest type of alkane is called methane. So there is something about these organic compounds, the ending of the name alkane should appear in the actual name of the compound. When you say methane, from A and E you say, or you write, I realize that you're talking about an alkane. One of the things that you definitely need to know about alkanes is that their formula is CnH2n plus 2. Means they have carbon and hydrogens, but if you consider n carbon atoms, you will have 2n plus 2 hydrogen atoms. Let's apply it on this methane molecule and experience it. What is the number of carbons in methane? You just have one carbon, right? So how many hydrogens do you expect? 2 times 1 plus 2 is what? 4. Don't you see 4 hydrogens? We said there should be 4 bonds around each carbon. So the first hydrocarbon is CH4 or methane. How about if you have, we'll talk about stuff like alkanes later. How about if you have 2 carbons, C2, how many hydrogens do you expect to have? 2 times 2 plus 2, right? So it would be C2H6. If you have 3 carbons, then you have 2 times 3 plus 2, which is C3H8. So, the name of the first 6 or 7 alkanes, try to memorize them. You have them on table, on page, on slide 18 and 19. 18 and 19. First 7 alkanes. Try to memorize them, it will be really useful. So based on that, slide number 18, what is the name of the second alkane? It's called ethane. Ethane. Methane, ethane. In any case, they end in A and E. The third one is called propane. Who hasn't heard about propane? When you want to grill, you go and get a propane cylinder, right? That's the same propane that you use for grilling and cooking. So you see, the stuff start making more sense, and we have a lot of daily life examples with organic chemistry. I'm sure you will enjoy it also, although it's very different. So I want you to know the names of the first 7 alkenes: methane, ethane, propane, butane, pentane, hexane, and heptane. If you pay attention, you go back to slide number 15, you will have a space filling model, you will see a ball and stick model, and electrostatic potential map of methane. Unfortunately, because we don't meet, we cannot work with the molecular models, but if you happen to have any molecular models from your sisters, brothers, your relatives, any students, or if you have it from previous semesters or you have it, feel free to work with them. But in just showing on the board, we use 2 types in this case. We use we call it line bond, and we call it another one, we call it condensed. So line bond, when you show the bond as a line, what I did with CH4 with methane. You see, I'm showing each bond as a line. For condensed formula, I need to show it for a larger hydrocarbon. If I have a hydrocarbon here like this, it would be the condensed formula. Let me start working on different structures so you will understand better. But so far, based on what you have learned, you have, like, let's say this is for methane. Let's draw it for ethane also. Ethane, you said what? If methane was CH4, then ethane had 2 carbons, right? 2 times 2 plus 2 is 6. So you have 2 carbons first, you connect them to each other. And what should you do for each carbon? You must have a complete octet, or 4 bonds around each carbon. You already have 1 on each carbon, so you need 3 more to make the octet complete, to make 4 bonds around this carbon complete, and then 3 more on this carbon. So C2H6. So at the same time that you have 4 bonds around each carbon, you are completing the number of hydrogens needed. So knowing this formula is extremely important, and knowing these names, methane and ethane, and their formulas are extremely important at this point. First 7 alkanes you need to know. Memorize first 7 alkanes. Okay, so you have the first 7 alkanes from on slides number 18 and 19. These first 7 alkanes, or first 10 alkanes, they're called homologous series, which are the compounds that they are different by adding the certain number of atoms. Like, for example, between CH2 and CH4 and C2H6, between methane and ethane, you are just adding a CH2. So they're called a homologous series. and you see them on the table on slide 21. They have similar, the homologous series, they have similar properties, like physical properties like melting and boiling points, as you see on slide number 21. Not very different from each other. I mean, by increasing the number of carbons, you see they change. And we get to the point that we need to introduce constitutional isomers. I will explain it since I'm going in the order of your PowerPoint slide, but I will prefer to talk about it in more details later when I name the compounds for you. So, constitutional isomers. You need to know the definition for constitutional isomers. Constitutional isomers, they're the compounds, they have same formula but different arrangement. So at this point, even without knowing the names, let me give you two examples. CH3, CH2, CH2, CH3. Let's say you don't know anything about naming organic compounds, but you're going to find the constitutional isomers between the given compounds. So let's say this is one of the compounds without knowing its name, and this is the second compound without knowing its name. And in each case, you can try it, you can examine it. Every single carbon has a complete octet or has 4 bonds. Even this one, this carbon, has 1, 2, 3 with carbons, and the fourth one is with the hydrogen. So let's find out if these two are constitutional isomers. They look different, means the arrangement is different. The first one is completely straight. All the carbon atoms are one after each other, and this is the condensed formula. And this compound is not completely straight. They call it a branch. This is a branch. It's like a tree branch, right? Sticking out of the compound. So, in order to find out if they are isomers or not, we don't care if you don't know their names. Just count the number of carbons. How many carbons do you have? 4. And how many hydrogens do you have? 3 plus 2, 5 plus 2, 7 plus 3, 8. So far this formula for this compound is C4H10. Let's count the carbons and hydrogens for this compound. I see 4, I count 4 carbons, and how many hydrogens? 3 and 3 and 3, 9 plus 1, 10. So, since the formula is the same, the number of carbons and hydrogens are the same formula, but different arrangement, I call them constitutional isomers. Constitutional isomers. Isomers are compounds of the same type, which are a little bit different in the arrangement and the number of carbons and hydrogens. Another name for constitutional isomers is structural isomers. Structural. So if you see any of them, there should remind you of same formula but different arrangement. Let's work on another one to make sure you got it. So far these two compounds are the constitutional isomers. But how about these two? Let me draw the structure. 1, 2, 3, 4, and 5. And this CH3, CH2, CH2, CH3. So let's count. We don't know, we don't care about the name. 1, 2, 3, 4, 5, and 6. You're supposed to count all the carbons whether in the main chain or in the branch. 1, 2, 3, 4, 5, and 6 carbons. And how many hydrogens? 3 plus 2, 5, 6, 8, 11, and 14. It's C6H14. And this compound, 1, 2, 3, 4, and only 5, C5. And how many hydrogens? 3, 4, 6, 9, and 12. Are they constitutional or structural isomers? No, none of the atoms are the same, not carbons, not hydrogens. So they are not constitutional isomers. That's how you determine the constitutional isomers. Don't worry about not knowing the name. Just count the carbons and hydrogens and determine it. That's all. All right. We are moving towards slide number 25 is extremely important. And the focus I put is on the alkanes, because if you know naming the alkanes and the structure of alkanes, you will be good for the rest of them, for unsaturated and aromatic. So let's focus on slide number 25. It's another very important slide, number 25. You will memorize the name of alkyl groups. Memorize alkyl groups, names and the structures. So, how to find the alkyl structures? This is the alkane. Okay, luckily we don't have too many of them, but alkane, and we will have the alkyl group. So I'll show you how to make the alkyl group from alkane. So the first one was methane, right? Methane. If you remove a hydrogen, you change it to a CH3, right? Instead of 4 bonds, there are 3 bonds around carbon. So this side, if I put a dash here or here, means that this compound, this CH3, cannot exist by itself. It has to be a branch sticking to another structure. And we will have them a lot, we will name them. But when you say alkane ending in A and E, you say alkyl ends in YL. So instead of methane, now you have methyl. Alright? I told you, the ending of the name in organic compounds must resemble the family, the group. The second one was ethane. Ethane. If we write the closed structure, it's just a CH3. Now the same, and now you know the drill. Minus 1 hydrogen, so you will have CH3, and let's say you're taking the hydrogen from here, so CH3, CH2, right? This hydrogen has a complete octet, but not this, this carbon, sorry, but not this carbon. So means that it cannot exist by itself. It has to be a branch on another structure. So instead of ethane, we call it ethyl. Ethyl. We will work on all of these when we are naming the structures. This third one is propane. Propane, CH3, CH2, we are showing the condensed structures, right? Condensed means packed, means zipped. CH2, CH3. It's called a propane, right? Remember? Grilling cylinders. Again, take a hydrogen out. Now, you see, by increasing the number of carbons, you have more choices of removing the hydrogen. So let's say we are taking this hydrogen out this time. So you have CH3, CH2 and CH2. Again, this carbon does not have a complete octet, does not have 4 bonds, and then you have to put a bond here. So if it was propane, it's called propyl. I told you, you need to memorize. There is no other way to learn them. I have memorized them, and I learned them by memorization. You can do that too. Now, in the propane, now you would say, how about if I take this hydrogen out? Because these two hydrogens have the same value. They're the same, right? They're both CH3 at the end. But how about I remove one hydrogen from this carbon? So, still propane, but you remove the hydrogen from, can I color code it? From this. So, you will have CH, and nothing happens to the CH3. So the location of the connection to the other compound is from the middle carbon. In organic chemistry, whenever is something going on the second carbon, you bring a prefix iso. So instead of just a propyl, which connection is at the end, the connection, whenever it's on the second carbon, you call it isopropyl. Please try to learn these well, because in the next video, I'm going to start naming, okay? So the difference between propyl and isopropyl is that the connection is from the first carbon on propyl, but on isopropyl, the connection is from the second carbon. And luckily, the last one that you will deal with is the butane with 4 carbons. So allow me to erase these to make some room in our little bitty board. Okay, so if you have a butane, remember after propane, you were supposed to memorize them. The name of the compound is called butane. So now you have more choices. You have 3 choices, and you have actually 4 choices, but we only introduce 3 of them. First, with butane, you just have 1 choice. So you have 2 choices, sorry. You can take this hydrogen out, okay? Take it out, then you will have CH3, CH2, CH2, and here instead of CH3 you have CH2. So this would be the location of connection, right? You had a butane, so alkyl group will change to butyl. Butyl. Okay? Now, if you move this carbon to over the second one, CH3, you remove one of the hydrogens. Don't forget, I'm repeating so many times, I make you tired, but I want you to learn that the carbon must have 4 bonds. So you take one hydrogen out, instead you put this CH3, and this carbon, you cannot leave it as CH3, so it becomes CH3. So the difference, what is the difference? These two are the same compound, I mean not the same compound, they're isomers, they're constitutional isomers. But didn't I tell you, when something is going on the second carbon, means when I moved the CH3 on the second carbon, instead of the butane, I bring the same prefix, isobutane. Remember the isopropyl? Now I have the isobutane. If I remove this hydrogen, then I will have CH3, CH3, and because I don't have the complete octet on this carbon, then the connection, the location is on this one. You call it a tertiary butyl. tertiary. At this point, please just memorize, because you will learn what is the meaning of tertiary, and it's abbreviated by T-butyl. T-butyl. Okay, memorize them. We will come back with more details about alkanes and cycloalkanes.